What is a tide?
It's like the water level, I guess.
Yep, it's a water level in big bodies of water, so oceans and seas, and some lakes do have a bit of a tide. What causes it? Anybody know what causes it?
Is it like the rotation of the moon?
Yeah, it's the location of the moon relative to the Earth. That's right. So the gravitational pull of the moon. Anyway, you don't need to know that. That's not any part of the math. Has anybody ever been where there's a big tide and you get like tide pools and stuff like that? Yeah? A couple people. Some people are nodding, I think. Some people are shaking their heads. So I actually spent a little bit of time in Durban, and where we were, the beach was very rocky, and when the tide goes out, in the rocks are all little pools, because the rocks aren't flat. They're all full of like holes, and like some of them are big pools of water. And when they say tide pools, that's what they mean. Like, think bits of water that are caught in the rocks when the tide goes out. Because when the tide goes down, the water level goes down. It also goes out the beach, right? Because it goes down the beach. When it comes up, the water comes further up the beach. Anyway, and like animals, like fish and stuff get caught in those pools. So you can walk around and sort of find sea creatures in them. Like we would find octopus and stuff like that in them. Like it's really interesting. Anyway, and so this is an example of an application of sinusoidal functions, as we call them, which again doesn't mean a sine function, it means sine or cosine. And the reason is, and imagine this, tide goes up to a max, tide goes down to a minimum, tide goes back up to a max. Doesn't that sound like a sine graph or a cosine graph? What other things in the world do that, like behave that way? Can you think of other examples? A pendulum would, yep, because it would go up to a max and then down to a min. Now, if you graphed the actual look of a pendulum, that wouldn't look like one, right? But if you were graphing the height of a pendulum, that's right. And it would be in an even increment, right? Yeah, because it would be the same time every time to go to max to a min. Good one.
What a roller coaster would.
Some kinds of roller coasters might. What would be a type of roller coaster that would have that? I can think of a pendulum type, like the pirate ship at Canada's Wonderland that goes back and forth. It's like a pendulum. Roller coasters have different peaks, and like it goes higher and then lower and then even higher and then lower. So that part might not be, but you could have a roller coaster that was like that. There's something like a roller coaster that certainly is sinusoidal. Yeah, Ferris wheel, right? Not really a roller coaster, but Ferris wheel, get on at the bottom, and it takes you to the top, and then in the same amount of time it takes you back to the bottom, and you would keep going around as many times as the Ferris wheel goes around. So like a person on the Ferris wheel, their height would follow a sine curve. That's one of the examples we're actually going to do in this course. A swing, yeah. So similar to a pendulum, so anything kind of like that. A yo-yo was one that I came up with, like if you were doing it consistently.
My energy during math class.
Yeah, your energy during math class goes up and down, or it just goes down. Daylight. The number of hours of light during the day goes up to a maximum in the summer and down to a minimum in the winter. And it does actually follow a very nice sine curve, and you can find this data online and like graph it in graphing software, and it'll look like a really nice sine or cosine curve. So the number of hours of sunlight is another famous application that we do. We don't actually do it really anymore because it's a hard one because of the X scale. So we kind of have started avoiding it a little bit more. If we had more time to spend on this, we'd probably do a day on it, but.
Wouldn't people technically, because your spine compresses and decompresses throughout the day, so you're taller in the morning and shorter in the evening?
Yeah, I wonder if it would follow an even period though. Like, would it be every 12 hours?
I mean, if you get consistent sleep, I'm sure it would.
Yeah, it could be, for sure. Yeah, that's interesting. And it would be a very small, your amplitude wouldn't be very big, right? It would just be a few millimeters or something. But, yeah, that's possible. There's lots of others. All of those you might think of as cosine curves, because you kind of think of them as starting at a max or a min. Like a Ferris wheel, you get on at the bottom, and it takes you to the top, and you come back down to the bottom, and takes you to the top, come back to the bottom, and you get off. So a Ferris wheel, you would think it'd be a cosine curve. Same with tides. We probably are going to start when it's low tide or high tide, just because it's easiest. So again, like the last lesson, you're going to find a lot of these cosine make sense. I've tried to think of examples where a sine would make sense. The only thing I could come up with is something like some kind of electrical field that starts at neutral and fluctuates between going up to a max and down to a min or something like that, right? Maybe that would kind of be naturally modeled by a sine curve. But for the most part, these are often with cosine. Just going back to that sunlight one, somebody tell me something about the sunlight in Alaska or like northern Canada.
They only get like sunlight for like certain times of the year.
Yeah, they have it's only a couple of weeks of the year, but there's a couple of weeks of the year that they don't get sunlight. It's just dark. And then what else? There's a couple weeks where they only get sunlight. So wouldn't that be a bigger amplitude? Where they're going from 0 to 24 throughout the year? Whereas we go from like, I don't know, 8 to 12 or something like that throughout the year, 8 to 14. Like ours doesn't fluctuate that much. But you do notice a difference. Certainly, especially if you're up driving early in the morning like I do, then you notice throughout the year that all of a sudden you're finally driving in the daylight again. So that would be a change in amplitude. And so kind of interesting way to think about it. And all of these do come down to those properties, amplitude and period and that kind of thing. So this is actually going to be very similar to the lesson that we just did. The only difference is the properties that it's giving us, like notice how it gives us a max and a min. Well, they actually mean something, right? But the last questions were giving us a max and a min as well. I just went like that, max and min. The other ones were giving us a max and min as well. They just weren't calling it anything. So if you were doing well with the last stuff, which I could tell a lot of people were, this is going to be very similar. So let's do this example. The tide off the coast of Durban, South Africa ranges from 0.8 feet to 6.4 feet and about 6 hours later. So it goes from the minimum to the maximum in about 6 hours and repeats one cycle every 12 hours. And that's a good connection to make based off of question E from the practice. And those of you that did it, you understand what I'm talking about. The relationship there, that kind of helps us understand everything. Okay. And pretty much every question is going to ask you to do these three things. We've got one extra question here, question D. You're going to sketch it. You're going to use the information and the sketch, I think, to come up with the equation. The same way we were just doing. And then you're going to use that equation to calculate something. Okay? Okay, so let's start with A. We're going to sketch this. Oops. So I'm going to call this depth. You could call it height, I suppose, which means this is going to be D. This is depth in feet. I'm going to call this time in hours. So I'm going to call it T. Now, I do kind of like to use a ruler to get my points to be relatively accurate. You don't have to. You could also eyeball by sort of doing the start and the end and then cutting it in half and cutting it in half again. But if you're good at eyeballing that kind of thing, then you might be fine. If you're not, you might want to use a ruler. What I want to avoid is doing something like this. Because we have to graph 2 cycles. So I want to make the cycles somewhat equal and similar because they should be. Okay? And so I just find using a ruler to be useful for that. So I'm going to go to about the half, which is 1, 2, 3, and put a point there. 1, 2, 3, and that'll be my end. Put a point there. And then half of that, and half of that. This just works well for me to get things split up correctly. So it doesn't say what to do here. Some of the questions do and some don't. Or some of them, like the Ferris wheel questions, inherently there's a place that you would start. I'm going to start at low tide. It just says over 24 hours. So I'm going to start at low tide. And this is a sketch, so we're not doing accurate graphing, but we are labeling everything accurately. So that's 0.8. And then I'm going to be at a max. And the max is 6.4. Then I'm going to be back at the min, then back at the max. And again, I could use my ruler to make sure that those line up nicely, and they don't. But don't overdo it. I just find that for people who have a hard time making graphs look nice, just a little bit of care helps. Okay. All right, now I'm going to connect all the dots. There we go. So this is 6 hours to go from the min to the max, 12 hours to complete a full cycle, another 6 hours, 18 hours, and then 24 hours. And I should have asked you this, but if one cycle happens in 12 hours and we're drawing 24 hours, then obviously we're drawing 2 cycles, right? So I've got 2 cycles of this tide drawn here. I've got my y-axis labeled, like my max and my min labeled. I've got sort of the key points. I haven't done those, but we don't usually worry about labeling those. But I've labeled all the maxes and all the mins along the horizontal axis, so that's kind of what you're expected to do. And I've labeled my actual axes and everything. So that's kind of what a full sketch should look like. Any questions? Okay, moving on to B. Determine an equation for this relation. How are we going to do that? Once again, if you just think of this tide question kind of big picture stuff, it might feel like, I don't know, I don't even know where to start. But what are we doing when we're doing an equation?
You find it
A, K, C, and D, right? That's what we're finding in order to write the equation. We're going to do cos, so y equals A cos k x minus c plus d. What do you want to start with?
Well, K would be 12 hours. 'Cause that's the,
K is not 12. 12 is the
oh, that's the period.
period, so K would be, so how do we find it?
It would be 2 pi divided by K? Divided by 12? Or like
Yeah.
pi 6?
2 pi divided by the period, 12, which is pi by 6. Okay? What else? How? Okay, so amplitude is max minus min divided by 2, so 6.4 minus 0.8 divided by 2. Has anybody done that yet? 14 over 5. Can you do that as a decimal? 2.8. So A will be what? Maddie? Close? Yeah, very good. Negative 2.8. And that's because I did make that choice. The question didn't say I had to, but I did choose to start at a minimum. So I got to make my A value negative. Amplitude is never negative, but A is negative. Okay, what else can I do? There's an easy one here. Yeah, the C is 0 because we're starting at a minimum and we're doing cos, right? And then what about D? How am I going to figure out that? Lillian.
It's the max minus the amplitude.
So we can do the max minus the amplitude. Oops, I don't know why I wrote it like that. I was getting ready to write a fraction. Minus the amplitude, and that works out to 3.6. The other way to do it is add the max and the min and divide by 2. That would have given it to us as well. Now that I have that, I'm going to actually add that to the graph. You don't have to. But the more information you can add to the graph, the easier it might be to like answer questions or just visualize things or make sure that you understand how everything works. Okay. And that's everything. So, therefore, oh, why? Whoops. So we usually use function notation for these. I called it D, and we usually use function notation, so D at T. Well, if you called this D and then you did Y, yes. The variable you pick will not cost you marks.
But like if you were to do D equals all of that, would that matter?
I don't know that it's about marks, but you should do it in function notation. It matters just in the sense that that's the notation we would tend to use at this point in math. Does that make sense?
Okay.
Yeah. Yep.
Could, like, let's say it was like 2.8 for A, and you like saw like the middle one. Would you just like put your C as like +6?
If you started there,
Yeah.
yes. Okay. So or D at T equals, now we're starting at a max, so 2.8 cos pi by 6 T minus 6. Same function. It'd be a little, that's a little weird to do when, you know, we specifically sketched it starting at 0 and then wrote an equation somewhere else, but it wouldn't be wrong, and on a test you would get full marks for that. Maybe the better thing would have been just to start at the max, like do your sketch starting at the max, right? And then you would, and then then it would be positive 2.8, and there would be no phase shift, but it would match your graph because your graph would look different, right? And you're writing an equation of your sketch. And if you chose to start at a max, but somebody else chose to start at a min, it makes sense that their equations wouldn't be the same.
Does it matter if we do X and Y, or do we just do D and T?
Well, generally speaking, I would say since grade 9, when we're doing applications, we pick variables that match the application. We use H for height, we use T for time. So you should be trying to do that, I think. If it was number of apples, you might use A or you might use N. Like that's the standard that we do. So you should try. Any other questions? Well, the other thing is, I guess if you found that point, you could write it in terms of sine. But again, why would you go ahead and do that? It's just a bunch of extra work. Okay, so C, what is the depth 2 hours from low tide? How do we do it?
You sub 2 in for T and then just
Very nice. Now, if we had used that formula, how would we do it? It would have been a little bit trickier, wouldn't it? So it's good that we have a formula starting at low tide, because that's going to help us. I guess you would have used like -4, so like you would have to kind of figure out the relationship between 2 and 6 hours or something. And that could be messy. That's not usually something you have to do. So at t equals 2, try that on your calculator. And what'd you get? 2.2. Good. Yep. You got 5?
I got 2.4.
2.4? Okay, so this is interesting. I will say this. Did you use brackets for multiplication on your calculator, either of you?
Oh, I did the exact same. Oh, no, I did the other one. I did like the orange one. The same.
Okay, so that's why it's wrong, because the orange one starts at high tide. Did you use brackets, Noor, by any chance, to do multiplication?
I did cos, and there was like one bracket, and then I did pi over 6 times 2 and then bracket. Whatever.
You didn't do this pi by 6 bracket 2?
Oh, no.
On Casio calculators specifically, I don't think it's other calculators. Some types of Casio calculators, when you do this, it puts the 2 in the denominator. Because some people might write it that way, I guess. Whereas you probably meant it to be the numerator. So be careful when you've got a fraction and then you're multiplying, that you just don't use brackets, I guess, on your calculator. Okay? But it sounds like that wasn't the problem for either of you. Okay. Last question. D, how many times a day is the depth exactly 6? So this is just we're going to look at the graph and just kind of get the graph to help us answer this question. So what's the answer? Andy? 4. So it's going to be right up here somewhere. 1, 2, 3, 4. Right? At about 6 feet. I guess if it said, how many times would it be 7 feet? That would be 0. There aren't that many questions like that, I don't think, but they're kind of interesting. There might be 1 or 2 in the practice. They're usually easy kind of thing. You're just using the graph to kind of visualize it, but they're kind of easy. I used to like to ask questions like this. Surfers want the tide to be high. They want more depth. I think it probably does bigger waves as well. I'm not sure of that though. So if high tide, if surfers needed a tide of 5 feet or more, when could they start surfing and when would they have to stop surfing? Like how long a day would they get to surf? Swimmers or people who are exploring tidal pools would want low tide. So if they want the tide to be below 2 feet, then you could calculate the amount of time per day or the times per day between which it would be safe to swim. Right? So, you could use your formula to kind of calculate those kinds of things. Any questions about that? About any of that? Last thing I want to say, when we switch over to the practice, a Ferris wheel has a radius of 25 meters and its center 26 meters above the ground, rotates once every 50 seconds, Draw a graph showing your height above ground how your height above ground varies with time for 2 revolutions. So you're supposed to draw a graph of a Ferris wheel. So is this what you do? This is not what it's asking you to do, but believe it or not, we get people doing this on tests occasionally. It's not asking you to draw a picture of a Ferris wheel. It is asking you to draw a graph showing the height of a rider over time. So a rider would get on at the bottom and go up and then go back down and go back up and go back down. Oh, it's a sine curve and a cosine curve like the stuff that we've been studying, obviously, okay? Now, drawing this can actually help, because I can start to label it. I might be given the max, 100 feet. I might be given the min, which is 2 feet. And I can use that to calculate amplitude, calculate the 0 line. Like, visualizing it this way might help. So this is a strategy that you can use to figure out some of the details. In fact, that one that I was just reading, I think it's not a bad idea to do a quick little sketch like this, but then you have to put it into a sinusoidal graph, okay? Just so you know.